two roads. One was built by Roman engineers more than 2,000 years ago. The other was built using modern machines and modern materials just 20 years ago. Yet in many places the ancient road is still standing, while the modern one is already cracking. At first, this seems impossible. How could roads built with stone, gravel, and hand tools survive longer than roads built with modern engineering? But the answer is not what most people expect. Because Roman roads were not simply paved paths, they were carefully engineered systems, designed to control something that destroys most roads today: water. And once you understand how Roman engineers managed it, the durability of their roads suddenly makes much more sense. To see why, we need to look closely at how Roman roads were actually built. Roman roads were not simple surfaces laid on the ground. They were built as layered structures designed to remain stable for long periods. Archaeological research shows that many Roman roads consisted of several carefully constructed layers. At the bottom, builders placed large foundation stones to stabilize the structure against shifting soil. Above this layer came compacted gravel, sand, and crushed stone, materials that helped distribute loads. Finally, tightly fitted stone slabs formed the road surface. Each layer had a specific purpose. The lower layers provided structural stability, while the upper stone pavement spread weight across the road. This layered design made Roman roads far stronger than simple stone paths. But strength alone does not guarantee longevity. Even the strongest road can fail if its foundation weakens. And the greatest threat to any road foundation is water. Water is one of the most destructive forces in road engineering. When water enters the soil beneath a road, it weakens the ground and causes the surface to crack or collapse over time. Roman engineers understood this remarkably well. To prevent water from accumulating beneath their roads, they built the road surface with a slightly raised center, a feature known as a camber. Rainwater would naturally flow away from the road toward drainage ditches along the sides. Studies have shown that this drainage system played a major role in preserving Roman roads for centuries. By controlling water flow, Roman engineers prevented the gradual weakening that destroys many roads. Yet even with such strong construction and excellent drainage, Roman roads were built for a world very different from ours. Roman roads carried pedestrians, horses, and wooden carts. Even heavily loaded carts exerted far less pressure than modern vehicles. Today, highways must support trucks weighing tens of tons, moving at high speeds and in enormous numbers. To handle these conditions, modern engineers often use asphalt, a flexible material that can absorb repeated traffic loads. Asphalt roads are cheaper to construct and easier to repair when they wear out. But this flexibility comes at a cost. Modern roads are designed not to last for centuries, but to be maintained and resurfaced periodically. The durability of Roman roads does not mean ancient engineers were more advanced than modern ones. Instead, it reflects different priorities. Roman roads were built to endure centuries with minimal maintenance. Modern roads are designed to carry heavy traffic efficiently and to be repaired when necessary. The materials changed, the traffic changed, and the goals of engineering changed. Yet, the survival of Roman roads reminds us of a fundamental engineering principle. The lifespan of any structure depends not only on technology, but on how well its design matches the forces it must endure. And sometimes the lessons of ancient engineering still echo across modern infrastructure.